We spend hours outlining potential articles, mapping out optimal workout splits, and researching the perfect diet plan. We tell ourselves we're making progress, but there is a strict divide between being in motion and taking action. Motion is strategizing, researching, and learning. Those are useful behaviors, but they will never produce an outcome on their own. Action is the physical behavior that actually delivers the result. If motion doesn't yield results, we have to ask why we spend so much time doing it. We slip into motion because it allows us to feel productive without running the risk of failure or public judgment. You might convince yourself that brainstorming book ideas is moving you in the right direction, but when preparation is used to delay doing the actual work, it stops being planning. It is procrastination. On the first day of class, a University of Florida professor named Jerry Yelsman divided his film photography students into two groups. The first was the quantity group. They would be graded strictly on the volume of work they produced. 100 photos would earn an A, 90 a B, and so on. The second was the quality group. They only needed to submit one single, theoretically perfect image for the entire semester to get their A. At the end of the term, Yelsman looked at the submissions. The best photos, the ones with the most compelling composition and lighting, were entirely produced by the quantity group. Throughout the semester, the quantity group had been actively busy taking photos, testing methods in the darkroom, and learning from their mistakes. The quality group spent that exact same time sitting around, speculating about unverified theories of perfection. Obsessing over the optimal approach leaves you with little to show for the effort. It actively prevents the acquisition of real skill. To understand why the messy repetition of the quantity group works, we have to look past human behavior and examine the physical biology of the brain. Neuroscientists observe a process called long-term potentiation. As you repeat a specific activity, the physical connections between neurons in your brain strengthen based on those recent patterns. This phenomenon was first described by neuropsychologist Donald Hebb in 1949, summarized in a clear principle: neurons that fire together, wire together. With every repetition, the cell-to-cell signaling improves. The neural network tightens, carving out a highly efficient physical pathway for that specific task. Long before neuroscientists mapped these networks, observers recognized the mechanics. In 1860, the philosopher George H. Lewis noted that learning a new physical movement is incredibly difficult at first, but as frequent repetition cuts a pathway in the mind, the difficulty vanishes. Action causes the physical, architectural remodeling of your brain. We can see this remodeling on a macro scale by looking at the famous studies of London taxi drivers, a profession requiring the daily memorization and navigation of thousands of complex city streets. When researchers analyzed the anatomy of these drivers, they found that their hippocampi, the specific region of the brain governing spatial memory, were significantly larger than the average person's. The brain responds to repetitive use just like muscles respond to weight training. The specific region grows to accommodate the demand placed upon it. The reverse is also true. When those same taxi drivers retired and stopped navigating the maze of London streets, their hippocampi atrophied and shrank back down to average size. Your biological capability is not fixed by your genetics. It is dynamically dictated by the frequency of your daily repetitions. This brings us to the most common question in self-improvement. How long does it take to build a new habit? You might have heard it takes 21 days, or maybe 30, but there is nothing magical about time passing. Simply waiting for days to tick off a calendar does absolutely nothing to embed a behavior. This chart maps the trajectory of behavior change. In the beginning, a new habit requires high conscious concentration, but as you stack repetitions, you approach the habit line. Once crossed, effort drops drastically, and the action becomes easier. It all comes down to the math of frequency. Performing a routine twice in 30 days yields almost no change. Performing it 200 times over that same period physically transforms the brain. You have to stop asking how long it will take and start asking how many reps it will take. The ultimate destination of this process is automaticity. This is the point where the non-conscious mind takes over entirely, and the behavior happens without active thought. This scatter plot displays a real-world learning curve, tracking someone building a daily 10-minute walking habit. The data clearly shows that automaticity scales upwards strictly with the number of repetitions. To reach this state of mastery, you have to abandon the endless search for the optimal strategy and simply initiate the physical repetition. Remove the friction. Stop mapping out every possible feature of your plan. Make the initial action as easy as possible so you can start immediately. The only way to drive real change is to stop theorizing about perfection and start putting your reps in.